Okay, we're going to start with graphing. Seems like it's been forever ago since we did that. But if I was going to graph this thing, I know it's a parabola. It's in vertex form. I can see the vertex is -3, -4. You can see that here and here. So I would graph -3, -4 right there. Now, I know it opens up, and I like to use the 1, 3, 5 pattern. If you don't know the 1, 3, 5 pattern, then you're going to have to make a table and start plugging junk in. And you can do that. Just plug numbers in. But I know that this thing has a special pattern because it's a parabola. I'm going to go up 1, and then up 3, and up 5, and shoot my parabola through. Okay, now, domain. Flatten it onto the x-axis. It's going to cover the whole x-axis. That means the domain is all real numbers. Range, flatten it onto the y-axis. It covers just this part of the y-axis. That looks like it's going from -4 to infinity. Bracket -4 to infinity. Axis of symmetry. Remember that axis is that line, that imaginary line that cuts right through the middle. That's going to cut through the x part of the vertex. X equals -3. Y-intercepts, looks like it's right here at 5. X-intercepts at -1 and 2, 3, 4, 5. -1 and -5. Increasing, decreasing. Okay, this is the thing that a lot of people struggle with. This graph is obviously increasing right here. Everybody knows that. But you don't look at the range, okay? I don't care about this number right here. I care about the domain on which this is increasing. So squash that green part onto the x-axis. We're only looking from, what, x equals -3? We're looking from -3 to infinity. That's where it's increasing, the interval in which it's increasing. Bless you. This part is where it is decreasing. And again, look at the domain. You want the domain, and it goes from -infinity to x equals -3, bracket. Okay, so pretty quick. As long as you can find the vertex and know your 1, 3, 5 pattern, that should be pretty easy to do. Next one I think is a little bit harder because it's a little bit harder to get your vertex, and that's where we want to start. You have to remember the vertex formula, which is -b/2a. So in this case, that's going to be -8/2 times a is 1, or 8/2, which is 4. And then you're going to plug that 4 in. So 4 squared minus 8 times 4 plus 15. That's 16 minus 32 plus 15. -16 plus 15 is -1. So my vertex is 4, -1. 4, -1. Again, in order to draw this, I'm going to use the 1, 3, 5 pattern. If you want to just plug numbers in, go for it. But I'm going to go up 1 and up 3 and 1, 2, 3, 4, 5, up 5. Now you'd want to pay attention to the number in the front. If that number is positive, we know that it opens up, like this one. If that number would happen to be negative, then we know it opened down. So pay attention to that. This one opens up, so I'm all good. Domain, squash it onto the x. It covers everything. That's all real numbers. Range, look at the y numbers that are covered. Only these y numbers are covered from -1 to infinity. So -1 to infinity is my range. Axis of symmetry, line right down the middle. It goes through the x number, 4, and so it's going to be x equals 4. Y-intercepts. I can't see the y-intercept on my graph, but we notice that this number right here is always the y-intercept. Okay, that number right there is the y-intercept, so the y-intercept would be 15, and yeah, I believe that could be 15 when you look at the graph. Now, look back at the last one, and please understand that the y-intercept was not this number. It's not the same thing. It's not the same form, okay? And the reason is because you'd have to expand out this binomial, x plus 3, FOIL it out, see what the number is, and then you'd come up with whatever that c number was, whatever that y-intercept number was. X-intercepts we can see on the graph are here at 3 and here at 5. 3 and 5. Increasing, decreasing. So it's increasing here, this half of the graph. Look at your domain. Your domain is right here. It goes from the middle number 4 to infinity. And decreasing. This part of the graph is decreasing. Look at the domain for that part of the graph. It's going from negative infinity to that middle number of 4. Zeros and multiplicities. This is something that's pretty easy, but I don't think that we covered it enough, so you probably don't really know how to do zeros and multiplicities that well. So let's get it. First off, don't look at that 3. You can't make a constant number into a 0. You'd need a variable. Only look at the variables. That's what we're trying to make 0. So we can see that 4 would make a 0. And negative 2 would make 0, and 5 would make 0. You should be able to get that pretty quickly, right? Those are the zeros in this problem. But multiplicity talks about how many times those factors repeat. Really, it's just talking about the exponent. So since this factor has an exponent of 1, that x minus 4 is only there one time. That's a multiplicity of 1. This factor has a multiplicity of 3, and this factor has a multiplicity of 2. So really, you're just looking at the exponent on that factor as for the multiplicity, but it's talking about how many times that 0 is repeated, and there's something about that that's going to affect the graph. We'll learn about that later. So if we look at the next one, don't look at this 2. You only look at the variables. There's definitely a 0 at negative 1 with multiplicity of 2. Okay, that's the easy one. But the other one is not quite set up yet. X squared minus 9, we want it to be linear factors. And so you'd have to think about factoring that into x plus 3 and x minus 3. That factors into x plus 3 and x minus 3. So we can see there's a 0 at negative 3 and another 0 at positive 3. But since that's to the first and that's to the first, those are each going to have multiplicity of 1. So then the next one, pretty much the same thing. Forget about the 4. You've got a 0 at 2 with multiplicity of 3. This one's weird. Okay, you might be able to see that in your head. You know, most people will say it's the opposite, and so they'll see that 4. But think about what we're doing. We're trying to find what makes 0. So algebraically, what you could do is add 4, divide by 3. We're literally finding what value would make it equal 0. This is a 0 value of 4/3. Now, I find a lot of people can do that in their head. Okay, 4/3 with a multiplicity of 1. And then this last one, you're going to have to factor x plus 5, x minus 5. Think about it as linear factors. So then we can see a 0 at negative 5 with multiplicity 1 and positive 5 with multiplicity of 1.